Hello. Today we will be multiplying and dividing rational expressions. A rational expression is a ratio of two polynomial expressions. Because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are similar. For example, when you write a fraction in simplest form, you divide the numerator and denominator by the greatest common factor. For example, 35 over 40. 35 is 5 times 7, 40 is 5 times 8, so they have a common factor of 5, so when we divide by 5, the 5's divide out and we're left with 7/8. Similarly, if we have a rational expression with a polynomial in the numerator, polynomial in the denominator, we can factor the numerator and factor the denominator and then divide by a common factor. So their greatest common factor was x plus 2. That would divide out. And then we have a simplified expression. Sometimes you can also factor out -1 in the numerator or denominator to help simplify a rational expression. So for example 1, we want to start by factoring both the numerator and denominator. So when we look at the numerator, we have a quadratic trinomial, so it's reverse FOIL. And we're thinking about what multiplies to -24, this number, and adds to -2, which would be a -6 and a +4. So that factors into x minus 6, x plus 4. In the denominator, notice that all three terms here would be divisible by 2x. So I'm going to start by factoring out 2x. And then the resulting quadratic trinomial, we've got c of -4, b of 3. What multiplies to -4 and adds to 3? That would be a +4 and a -1. So those are the numbers that go in our factors. Now you can see that we have a common factor of x plus 4, so we're going to divide out the like factor. And our result is x minus 6 over 2x times the quantity x minus 1. State when the expression is undefined. So dividing by 0 is undefined. So to go back to your denominator, this part where it was fully factored, and any value of x that would make a factor 0 is when it's undefined. So what would make 2x 0 would be 0, -4 plus 4 would be 0, and 1 minus 1 is 0. So the expression is undefined when x equals 0, x equals -4, or x equals 1. In example 2, our denominator is already factored. The numerator is sort of factored, but I look here at this first factor, 6x squared minus 5xy. They have an x factor in common, so I'm going to factor out the x. And then notice here we have 6x minus 5y, but here we've got 5y minus 6x. So it's just kind of the opposites. Think about if you had 3 minus 7, you get -4. If you flip it around, you get +4. What we can do is factor out a -1 from this expression, and then it becomes -x times +5y minus 6x. So now you can see that these factors are the same, and we can factor that out. And then this is our simplified expression that's left after we've divided the greatest common factor out. To multiply rational expressions, multiply the numerators and then multiply the denominators. To divide rational expressions, multiply the dividend by the reciprocal of the divisor. For all rational expressions, of course, our denominators cannot equal 0 because dividing by 0 is undefined. A complex fraction is a rational expression with a numerator and or denominator that is also a rational expression. So you'll see usually a fraction within a fraction. To simplify a complex fraction, first rewrite it as a division expression. So in example 1, we're multiplying. So we are going to multiply, but first I'm actually going to write it in prime factorization. So 8 is 2 times 2 times 2. And then 12 is 4 times 3, and then 4 would break down into 2 times 2. So it's 2 times 2 times 3. I expanded our powers. And then 9 equals 3 times 3. And I expanded our powers. This makes it easier to show dividing out like factors. So canceling out all the like factors that we can, we're left with x squared over 2y cubed. For part B, to divide by a fraction, we multiply by the reciprocal, and then I will factor all the expressions. So 10, we break down into 2 times 5, expanding d to the 5th, and then for 4, we write 2 times 2, and then we had 6, break that up into 2 times 3. For 30, that's 6 times 5, you break down the 6 into 2 times 3, and then we will cancel out like factors. So we have a common factor of 2, common factor of 5, a couple more factors of d, another 2, and c. So after all like factors divide out, we're left with 2d squared over 9c squared. So if they still had a common factor, I would know I didn't fully simplify it. But our numerator and denominator don't have a common factor other than 1. Example 4. A manufacturer that creates and sells rectangular planters wants to compare the area of the top section of two potential sizes of planters. For some given measure x, the area of the first planter is represented by x squared plus 15x plus 50 all over x plus 2. And the area of the second planter is represented by x squared plus 30x plus 200 over x plus 2. Write and simplify an expression that represents the ratio of the area of the first planter to the second planter. So ratio means we're dividing. So remember that when you divide, you multiply by the reciprocal. Now we want to factor all the expressions that can be factored. So for x squared plus 15x plus 50, we have a quadratic trinomial where the leading coefficient is 1. So we're going to think about what multiplies to 50 and adds to 15, which would be 5 and 10. And then for the denominator in the other fraction, we want to think about what multiplies to 200 and adds to 30, which would be 20 and 10. So our expressions in factored form are x plus 5 times x plus 10, and then we have x plus 20 times x plus 10. And then dividing out our like factor of x plus 2 and x plus 10, we're left with x plus 5 over x plus 20. So this is what would be called a complex fraction. So you've got fraction within a fraction. So first write this fraction bar in the middle here as division. Then know that when you're dividing by a fraction, you multiply by the reciprocal. Next, we want to factor any expressions that we can factor. So I'm going to start with the 4x squared minus 4y squared. So first we would factor out a 4, and then x squared minus y squared is the difference of squares. That would factor into x plus y, x minus y. And 4 breaks down into 2 times 2. And then with this denominator, 6xy, we can factor 6 into 3 times 2. So then we'll cancel out like factors of x, x minus y, 3, and 2. So our final answer is 2 times the quantity x plus y all over y. Thank you for watching.